Hi students, now this is question number 7. We have it is like this question number 6. We have the spring, we have a mass, and this mass under two forces, the weight downward and the Hooke's force upward. At equilibrium, the weight downward is equal to the restoring force upward. The weight is mg. The Hooke's force is kx. The mass is 5 kilograms. The change in position or the expansion in the spring length is 30 centimeters, which is 0.3 meters. We need to find the spring constant k. Okay, we use this one now. Because we have an equilibrium, that means we will use the first Newton's law, which don't have any forces. The acceleration is 0. So the summation of all the forces are 0. The weight force downward plus the restoring force upward is equal to 0. We just need to order the terms to find that k is equal to mg over x. It is simple. Then k will be equal to, just put mg over x, which is 0.3, then 163.3 newtons per meter is the value of k. The second, if we have any oscillation motion, any vibration in this system, what is the properties of this vibration? We need to find in B the time period. We know this relation again and again. Okay, omega is equal to 2 pi f. This is angular velocity or angular frequency. This is the frequency. This is the angular frequency. It is 2 pi f, which is equal to 2 pi over t, which is equal to the root of k over m. It's simple. So t is equal, as we find that before, t, just we need to use this term and this term. Put t here and put this term in the denominator here, 2 pi over the root of k over m. It will be equal to 2 pi over k over m. K is not found, and m is 5. It will be tau now 1.099, approximately 1.1 seconds. In seconds, okay? Now, what we need to find next, omega, the angular frequency. It is equal to k over m, 2 pi over t, 2 pi f. Omega is equal to k 163.3 over the mass is 5. It will be equal to 5.715 radian per second. We can find the frequency. We just need to divide this over 2 pi. Between this term and this term, just divide over 2 pi. Omega is known now, 5.7 إلى آخره over 2 pi is equal to 0.9, approximately 1 hertz, or maybe sometimes you will see it second to minus 1 or 1 over second. All of them are the same. It is hertz, the unit for the frequency. Okay, the final part now. If we have the position, we know that the relation of position is x of t is equal to a cosine omega t. It is constant. It is known. A is constant. If we know that x, the position at the time t equal 24 seconds, is equal to 12 centimeters. How much A? We have x of t. It is a function. X of 24 is equal to a cosine Omega is known. How much omega? Tell me how much omega is. 5.715 multiplied by the time, omega t, 24. In this case, A, we just need to divide over this value. Put it here. Then A will be equal to 24.997, which is equal almost to 25 centimeters. It is like this. Okay, this is the 7th question. Please solve by your hand.